Yeah. Yeah, sorry for the interruption. Just a technical issue. Okay. So this is one of the very important lesson for our JEE and NEET exam. Okay, which consists of more weightage. And so we have to concentrate more on this, and one of the very important lesson in your class 11. Okay. You can't see the screen, or you can't see me. Can you see me now? And is my screen visible? Yes. Okay. Okay. Fine. Okay. So before moving on to the lesson, I just want to ask you a simple question. Okay. So what is the full form of LPG? Can anyone answer for this? What is the full form of LPG? It is a very, very easy question. So all of you can try for this. What is the full form of LPG? The full form of LPG is liquefied petroleum gas, right? Which we are using in our yeah, good, Shivashankar. It is liquefied petroleum gas. Good. So this LPG is acting as a gas fuel in our homes, which we all know. And petrol and diesel, you can see, those are the liquid fuels, right, in our daily life. And the kerosene is also a liquid fuel. Kerosene is also a liquid fuel. So all these fuels, if you can see, they contain, yes, good Hashira, it is liquefied petroleum gas. So all these fuels, they contain hydrocarbons. All these fuel contain hydrocarbons. Okay. So in this lesson for today, we are going to study the introduction to hydrocarbons and the classification of hydrocarbons, introduction to alkanes, isomers and nomenclature of alkanes, and preparations of alkanes. Okay. And under preparation, there are three preparations we have for alkane. First preparation is from unsaturated hydrocarbon, which is otherwise called as hydrogenation reaction. And the second preparation is from alkyl halides. Third preparation is from salts of carboxylic acid. Okay, we'll try to complete these topics as time permits. Okay, fine. So moving on to the first topic, which is the introduction to hydrocarbons. So what is a hydrocarbon? So do you have any idea? Any of you have any idea about the hydrocarbon? What is a hydrocarbon? What is a hydrocarbon? Any idea for any of you? So from the name, can you guess what is a hydrocarbon? They are hydrogen and carbon containing system. Hydrogen and carbon containing compounds are called as hydrocarbons. Okay. So it is a compound of carbon and hydrogen only. No other atom should take part in it. Okay. No other atom other than carbon and hydrogen should be there. Okay. So those compounds which contain carbon and hydrogen only are called as hydrocarbons. So it is one of the very important source of our energy, which I have shown you, right? In petrol and diesel. And in CNG, CNG means compressed natural gas. CNG is a compressed natural gas, and it is also a fuel. And for domestic purpose also, we are using this hydrocarbon only. Got it? So it is one of the very important source of energy, which consists of carbon and hydrogen only. Got it? Now moving on to the next part. So some more points I want to tell you about this hydrocarbon. Okay. So they are the monomeric units of various polymeric products. They are the So when you combine more monomers, yes, Sakshi, they are carbon bonds with hydrogen. Good. So when you combine more monomers, you will get a polymer. Like for example, we have plastic bags, plastic bottles, etc., etc. Right? So they are the low density polymer. So how do we get this polythene? How polythenes are formed? They are formed from a molecule called ethene. So ethene is a monomer. Ethene is a monomer, whereas polythene is a polymer. So what is the meaning? So monomeric units. So this monomer, this ethene monomer, it is nothing but a hydrocarbon. The formula for ethene is C2H4. Okay, it is a hydrocarbon and hydrogen containing compound, which is the hydrocarbon. So those monomeric units of various compound, they form the polymeric products like polythene bags, plastic bottles, polythene covers, etc., etc. Okay. Not only low density polythene, some high density polythenes are also there, which is used for making. You can see it in the picture, right? So which is used for making the bowls and for plastic tumblers, etc., etc. Okay, and lot of domestic purposes we use this plastic products, right? So they are high density polythene. And some more are there. Polypropylene. So in the last slide, I have shown you the polymer of ethene. Now this is a polymer of propene. So that's why it is called as polypropene. So the formula for propene is C3H6. So this is propene. Okay, when you combine more number of propene, you will get polypropene. And plastic buckets, which are just a little bit thicker than the normal plastic bags. Okay, they are made of polypropene. And also polystyrene cups. You might have seen this in all the shops, right? So polystyrene cups. Styrene is a monomer. Okay, so one of the very important example for hydrocarbons. So these are some of the introduction related to hydrocarbon and its uses. Now, secondly, we go for the classification of hydrocarbon. Okay, so now we will move on to the classification of hydrocarbon. So how they are classified. So let us see that. So before moving on to the classification, I just want to ask you a question whether the introduction part is clear to all of you. If it is clear to all, just give a thumbs up or type yes in the chat box by showing your interest. Or if you're having any doubt, just ask me your doubt. I'll clear you. Everything so far discussed is clear for all. So the definition for hydrocarbon I have told you, and some of the uses we have seen. So any doubt in that, students? Clear. Thank you so much, Anita. Yes, good. So now I'll go for the classification. So hydrocarbons are classified. Yes, thank you, sir. Hydrocarbons are classified into three. Okay, hydrocarbons are classified into three. The first one is called as saturated hydrocarbon. Okay, and the second one is unsaturated hydrocarbon. And the third is aromatic hydrocarbon. So what are saturated hydrocarbons? So the compounds which contains only carbon-carbon single bond are called as saturated hydrocarbon. Okay, and unsaturated, you can see the system contains carbon-carbon double bond and carbon-carbon triple bond. Okay, those are unsaturated. And the third classification is aromatic. In the last lesson itself, I have told you what is aromatic, etc. Right? Aromatic and the criteria for aromaticity. Those things we have discussed in our previous class. Right? So those are aromatic hydrocarbons. And here also in this lesson, we will discuss about this aromatic compounds. Now, this first saturated hydrocarbon is again classified. Okay? So saturated hydrocarbons are again classified. Yes, Sakshi? You have raised your hand, it seems. You have any doubt? Okay. If you're having any doubt, okay. No problem here. No problem. Just by mistake, you have done anything, no issues. Okay. So saturated hydrocarbons are classified as alkanes and cycloalkanes. Okay. Alkanes and cycloalkanes. So for alkanes, you can see alkanes are open chain containing system. So the example for an alkane is given to you, which is C2H6, and the name of this alkane is ethane. Since this alkane contains two carbon, it is called as ethane. Okay. And coming to the cycloalkanes, they are the cyclic system of saturated system. So in this example, you can see we have a 6-membered ring, which is called as cyclohexane. The name of this compound is cyclohexane. Got it? So in these two compounds, let me show you the complete structure of this ethane. So it is C2 and H6, right? So in this compound, you can see there is only carbon-carbon single bond present. In all this case also you can see the cyclic compound also you can see there is only carbon-carbon single bond. So those are coming under saturated hydrocarbons. Okay. Now coming to the second classification, unsaturated hydrocarbons, they are also classified into two. The first classification is alkenes, which have carbon-carbon double bond, and an example for alkene is C2H4, which is called as ethene. So just before we have seen the polythene. So those polythenes are made up from ethene. And the second classification under unsaturated is alkynes. Alkynes are carbon-carbon triple bonded system. The example for alkyne is C2H2. The name of C2H2 is ethyne. It is an alkyne, right? So two carbon containing alkyne. So it is called as ethyne. Got it? And the aromatic compound. So it is a special type of cyclic compound. Aromatic compound. There is no classification under aromatic. So it is a special type of cyclic compound. And the very important and very common example that we used to give for aromatic system is benzene. Okay. So the formula for benzene is C6H6. Okay. And this is called as benzene. So you should not get confused with cyclohexane and benzene. Okay. In benzene, we have carbon-carbon double bond. In cyclohexane, we have carbon-carbon single bond. Got it? So this is the classification of hydrocarbon. Very simple and very easy. So you should not have any doubt in this. Clear for all? If the classification, this flowchart is clear to all of you, just give me a response by typing yes, yes. Okay, thank you, Aisha. So now let's move on to the third topic for today's class. That is yes, yes. Thank you so much for all. Now let me move on to the introduction to alkenes. So what are alkenes? Any idea? Do any of you have any idea about the alkenes? Open chain and closed chain difference you need? Yeah, I'll tell you. So open chain means here we have cyclic system in the closed chain. The ring is closed, but whereas here it is not forming a ring, right? It is just an open chain structure. Like for example, let me take hexane for you. So in hexane, how many carbons we have? 6 carbon, right? 1, 2, 3, 4, 5, 6. So this is called as hexane. This is called as hexane. But in case of cyclohexane, still we have 6 carbon, but it is in the cyclic form. So that's why it is called as cyclohexane. That's why it is called as cyclohexane. So the first one is open chain system, and the second is the closed chain system. Clear now? Ring is closed. There we have a chain. There is no ring formation in the open chain system. Clear? Yes? Okay. Okay, fine, Sakshi. So now let's move on to the introduction to alkenes. So yeah. So I have asked you all a question, right? Any idea about the alkenes? Do you know any points related to this alkene? So who are alkenes? Who are alkenes? Yeah, very good. They are single bond, carbon-carbon single bond containing system, which are nothing but the saturated open chain hydrocarbon. Right? They are the saturated open chain hydrocarbons. Got it? So saturated means there will be only carbon-carbon single bond. Got it? You can see carbon-carbon single bond here. And this alkenes are otherwise called as, or it is also known as paraffins. It is also known as paraffins. Okay. So they are basically very less reactive and they are inert under normal condition. Normal condition means under in room temperature and pressure, they will not react with anyone. So that is the meaning of inertness. Okay. So since they are inert, they are called to be less reactive. Okay. So what is the first point? They are saturated open chain hydrocarbons and they are also known as paraffins. Got it? So the third point about The third point about the alkane is the general formula. So general formula for an alkane is CnH2n plus 2, where n belongs to a natural number, where n is a natural number. Okay, so it goes from 1, 2, 3, 4, etc. If n is equal to 1, what is the formula for this alkane? Substitute n is equal to 1. So you'll get CH4. You'll get CH4, which is called as methane. Okay. And if n is equal to 2, what is the formula? It is C2H6, right? So it is called as ethane. And if n is equal to 3, the formula will be C3H8. So this is called as propane. Okay. So like this, you can substitute the values for n and you can get a big class of compounds of alkenes. Okay. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. We have already studied this in the previous lesson, right? So the same thing. Got it? So just memorize this formula. That is it. CnH2n plus 2. The variant is a natural number. Got it? So the third point about the alkane is the general formula. Okay. So coming to the fourth point, fourth very important point for alkane is the hybridization. The hybridization of an alkane is sp3. The hybridization of the carbon in the alkane is sp3. So I'll show you an example. So here is the example for you, which is CH4. It is a CH4 molecule, and the CH4 molecule is tetrahedral in geometry. It is tetrahedral in geometry, and the hybridization of this particular carbon, this is called as methane, and the hybridization of before slide, I'll show you. Okay, this is the slide you were asking, right? My dear, who have asked the previous slide, this is the slide you were asking of? Yes. Okay. So have you noted down? Shall I move on with the next slide? Divyanush, shall I proceed with the next slide? Yes. Thank you. So what I have told you, the hybridization. Yeah. Hybridization is the mixing of, intermixing of atomic orbitals. You might have studied about the hybridization in the chemical bonding lesson, right? So for alkanes, means for all the carbon which are having only single bond, they are sp3 hybridized. Okay. So the hybridization of this carbon is sp3 hybridized. Got it? So for all the sp3 hybridization, the bond angle is 109.5 degree, which is very, very, very important for you. Okay. So the hybridization, if the hybridization is tetrahedral, yeah, I'll explain you what is a tetrahedral. Yeah, sure. I'll come to that. Okay. So talking about the hybridization, I told you it is sp3. All the sp3 hybridized system will have 109.5 degree as the bond angle, which is otherwise called as the tetrahedral bond angle. Okay, it is otherwise called as tetrahedral bond angle. Okay, so now what is a tetrahedral? What is a tetrahedral? So tetra means 4. Tetra means 4, right? So there are 4 phases. There are 4 phases for this system. So there is a carbon, and one carbon is attached with how many hydrogen? 4 hydrogens, right? 4 hydrogens we have. Now let me connect all these. Let me connect all these hydrogen with one another. Okay. Now, so I'll select a different color. So where is the color? Yeah. Sure. Now, just see, there are 4 phases for this tetrahedron. So this is the first phase. This is the first phase, front phase. Okay, that is the first phase. And the second phase. And the second phase is this left phase. This is the left phase, which is the second phase. And this is the third phase, right phase. And bottom we are having one phase. No, that is the fourth phase. Clear for all? So front, yeah, 4 phases. Front phase, This is your left face and this is the right face and this is the bottom face. So there are 4 faces for this structure. That's why it is called as tetrahedral. Clear? Clear for the student who have asked this doubt? So here you can see it very well, no? So this is the right face and yeah, this is the left face and that is a back face and bottom face. So that is a tetrahedron. So that will be like this. In the first class itself, I might have shown you. While teaching GOC lesson, I have taught this. Okay, like how a tetrahedron looks like. So you can go through those videos and you can get to know more about them. Got it? So the very important point about this particular slide about the alkanes are the hybridization, okay, and the geometry and the bond angle. Okay, these 3 are very, very important. Okay, so now I'll go on with the next point. Why is the angle between us? That is a tetrahedral bond angle, na? That is a tetrahedral. So, okay, let me take a square. Let me take a square. This doesn't look like a square, but anyway, okay, let me erase and draw a new one for you. Okay. So, Divyanush, just listen. So, this is a square. So, what is the bond angle? What is the bond angle for this square? What is this angle? It is 90 degree, right? Yeah, it is 90 degree. No, it's the same way. So, all the tetrahedral system, they are making 109.5 degree as the bond angle. Like a square makes 90 degree. Clear? The orientation of the hybridized orbital of carbon makes such 109.5 degree as a bond angle. Clear? Yeah. Fine. So everything is clear for you all till this slide, right? If you're having any doubt, just put it in the chat box. I'll explain you for sure. So now I'll go on with the next slide. Higher alkanes can be derived by replacing the hydrogen with CH3. So what we took, the first member of the alkane is methane, right? And the formula for methane is CH4. So in this CH4, I'm having 4 hydrogen. So if I am going to replace one of this hydrogen by a methyl group, I will get the second derivative of this alkane. Okay, so now let me replace. Now one hydrogen is removed and that hydrogen is replaced by CH3. Okay, so because of this replacement, what I'm going to get? I'm going to get CH3 and CH3, which is nothing but C2H6 and it is called as ethane. Okay, and what is the difference between these two formula? What is the difference between these two formula? So C2H6 is ethane and CH4 is methane, right? What is the difference? So 2 carbon minus 1 carbon is 1 carbon and 6 hydrogen minus 4 hydrogen is what? 2 hydrogen, right? Yeah. So CH2 is the difference between these two members. So if you take the third member, if I am taking this hydrogen, if I am trying to replace this hydrogen with one more methyl group, what I will get? I will get CH3. Okay. And what is there adjacent to this? I am having one CH2. And now I have replaced this hydrogen with one methyl CH3 group. So now I am replacing that. So this is the group which has got replaced. Okay. Now what is the formula for this compound? It is C3H8, right? Now what is the difference between C3H8 and C2H6? So again the difference is CH2, right? So every two consecutive members of alkene series, they differ by CH2 unit. They differ by CH2 unit or 14 AMU. 14 AMU means AMU is the atomic mass unit. Okay, so the atomic mass of carbon is 12 and for hydrogen is 1. Since we have 2 hydrogen, it is 2. So 12 plus 2 is 14. So they are differing by 14 atomic mass unit or they are differing by CH2 unit. This is what we are trying to say for this. Okay, so like this only we are generating the class of alkanes. Okay, so I hope this is clear to all of you. So next I'll go on with the 4th topic of today's class, which is the isomers and nomenclature of alkanes. Isomers and nomenclature. Isomers and nomenclature, already we have discussed this in the previous lesson. Now we are specifically going to see for alkanes. Okay. So talking about the isomers, alkanes generally show chain isomerism. Alkanes generally show chain isomerism. So any idea about the chain isomerism? In the last lesson, we have discussed what is chain isomerism, right? Do any of you remember the definition for chain isomerism? Or can you tell me what you have understood from the chain isomerism of last lesson? Any idea? You guys can try for it, right? Arrangement in a chain. Okay. Arrangement which is getting arranged in a chain. So isomerism means same molecular formula but different structures. Right? That is isomerism. So now what is the definition for chain isomerism? Molecular formula is going to be same. Who is going to get differ? Which will differ in chain isomerism? Arrangement in a chain. Yeah, that is a partially correct answer only. Can someone try for the more appropriate answer, or can Sakshi itself can try for the more appropriate answer? Okay. Different structure. Yeah. Yeah. Different structure means they are structural isomerism, and under structural isomerism only this chain isomerism will come. Under structural we have many isomerism, right? Chain, positional, functional. So those are also the structural isomerism only. But the exact and the appropriate definition for chain isomerism is they differ in the carbon skeleton. Okay, they differ in the carbon skeleton. So the compounds which have same molecular formula but different carbon skeleton are called as chain isomers. Okay, I'll show you an example. So I have took C4H10 as an example for you. So this is the structure of C4H10. Okay, all the carbon atoms you can see they are arranged in a chain, straight chain manner, which is called as N-butane. And coming to the second structure, which you can see. So here there are 3 carbon atoms in a straight chain manner. So these 3 carbon atoms are in the chain, but 1 carbon is branched. So 3 carbons in a straight chain manner and 1 carbon is branched. Okay. Whereas in the first case, all the 4 carbons are having a straight chain structure. Got it? So one is in a straight chain form and the other one is called as branched. So they differ in the skeleton of the carbon. That's why they are called as chain isomers. But if you see the formula for both the compound, they are same. They are C4H10. But one is N-butane and the other one is 2-methylpropane. So they are different compounds of same molecular formula and they are differing in the carbon skeleton. Got it? So this is an example for chain isomerism for you. So is this clear for all? So in the exam, they will give you one formula and they will ask you like how many chain isomers are possible for this particular formula, or which among the following is the isomeric pair of the given compound. Okay, so like this questions you may get in your exams, your JEE and NEET exams. Okay, so the given compound is an example of dash isomerism. Got it? So it is an example for chain isomerism. So butane and 2-methylpropane are the examples of dash isomerism. So in that case, what you have to do? You have to convert this name to a structure first. Okay. After getting the structure, you will come to know the type of isomerism. Okay. Shall we go on with the? Yeah, here see that's a straight chain and there is a branch. So I'll show you one more example. So one more example is C5H12. So what is the name of C5H12? It is pentane, right? So it is pentane, C5H12. If you substitute N value as 5, you will get C5H12. It is pentane. So this is the straight chain arrangement of pentane. And it is called as N-pentane. Now, if I put one branch, so there will be 4 carbon atoms in a straight chain manner and 1 carbon atom is branched at the second carbon. Now the name of this compound is 2-methylbutane. So all these nomenclature part we have already discussed in the previous lesson, and here also I will discuss after discussing this isomerism. Okay. Now to the second carbon, methyl group is attached. So that's why it is called as 2-methyl butane. And if I substitute 2 branch, if there are 2 branches, then it is called as 2,2 dimethyl propane. It is called as 2,2 dimethyl propane, which is otherwise called as neopentane. Okay, now these 3 compounds you see, one is in a straight chain manner, and in the other one we are having 1 branch, and in the third compound we have 2 branches. So the skeletal structure is differing, no? That's why they are called as chain isomers. Okay, so there are 3 chain isomers possible for the formula C5H12. Okay, clear for all? Good. So now let's see the different types of carbon. Now we are going to see the different types of carbon. So based upon the number of carbons attached to a carbon atom, the carbon atom is termed as primary, which is not clear. This is not clear, Aisha. Which one you want me to explain? This isomer, pentane isomer? Okay, okay. So see here. So all the carbons, all the carbons in the first compound, they are arranged in a straight chain manner. All the 5 carbons are arranged in a straight chain, linear form. Right? When I come to the second carbon, 4 carbon atoms there in the linear chain, and 1 carbon is branched. Okay? And coming to the third structure, 3 carbon atoms are there in a straight chain, but 2 are branched. Okay. So what happens here? 1 is in the linear fashion, and in the second compound there is 1 branch, and in the third compound there are 2 branches. So they differ in the skeletal structure of the carbon. So that's why it is an example for chain isomerism. Clear now for all who have asked this as a doubt? Clear for all of you? Yeah, okay. So now I'll continue with the types of carbon. So based upon the number of carbon atoms attached to another carbon atom, the carbon atoms are termed as. So now, let me take this as an example. Now there is a red color carbon atom shown to you. Now you can see this red color carbon atom is attached with only 1 carbon. It is attached with only 1 carbon. Yeah, that's what I have told you. Yes, Shamila, that's what I have told you, no? So like they will give you a formula and they will ask you how many number of chain isomers are possible for this formula C5H12. Or the given example, the given what is the isomeric pair, what is the isomeric compound for this particular compound. They will give you butane and they will ask you the isomeric pair. That is, you have to find out the 2-methyl propane, you have to find out. Okay, like that, they will ask you the other compound of 1 compound. And they will give you 2 compounds, or they will give you all the 3 compounds. And they will ask you the type of isomerism existing in that. Okay, that type of question can be asked. And what else? Or they will give you the name. They will give you all the 3 compounds name. And they will ask you to find out the type of isomerism existing among those 3 names. Okay, either they will give you the structure or they will give you the name. If they are giving you the name, just convert it into a structure. You all know how to convert a name to a structure, right? So in the last lesson itself, we have studied under the nomenclature part. So just like that, you convert and then find out the answer. It is going to be very easy for you. You will get trained in this. Once you complete your 12th standard, you will get trained in this. So there is no issues. Since you are studying this for the first time, it may be little bit difficult for you all. So when you revise again and again, it is going to be very easy. So in the first class itself, I told you all the organic lessons, they are very, very, very important for you. So all the lessons are having more weightage. And after this deletion, you might have noticed. So not even a single lesson of organic is being deleted. Okay, only polymers lesson is deleted. That is true from class 12. Oh, that is not a big deal with organic. So it is a kind of organic, okay. But all the pure organic lessons, there are actually 6 pure organic lessons, and not even a single organic lesson is deleted. They are very important, which has very high weightage for your exams. Okay, more number of questions will be asked from organic, especially for NEET students, and for JEE also the same case, since there is no deletion in this part. Okay, and it is going to be very easy only if you are studying it every day. Consistency is very important, right? So daily you have to study. That is called consistency. So every day you have to at least go through the organic part for at least 15 to 20 minutes. So in class 11, you're having only 2 organic lessons. One is some basic concepts of organic chemistry, and the other one is hydrocarbons. So only 2 lessons. It is not a big deal. You can go through for 15 to 20 minutes, and you can solve some around 5 to 10 questions on these 2 lessons every day. Okay, so that it is going to be very easy for you. So if you are not consistently studying this organic lessons in your daily basis in your study time, it is going to be a little bit difficult only, because all these consist of a sort of reaction type, right? So if you are studying a reaction today, okay, and then you are not looking into the same reaction tomorrow and the day after tomorrow, and you are taking the reaction which you are studying today on the or what I can say, after 2 days only you are opening the book. When you see at that time, all your reaction will go off. It is volatile. Okay, so that's why I'm asking you to study every day. Very, very important. Consistency is very, very important. Every day you have to just go through. Just open your notebook and see the reaction. That is enough. Just open the notebook and see the reaction. That is enough. Got it? So I hope the part which I have spoke today with you all is very important. You will realize when you come to your 12th standard. Okay, better you start preparing from now onwards. Got it? You are all at a very right stage. So all of you can prepare well for your exam and do your well. You will be writing in next year, right? Yeah. So do it. No issues. Yeah. Coming to the lesson, if a carbon is attached with only one carbon, it is called as primary carbon. And in the second structure, you can see the red color carbon is attached with 2 carbon. So it is called as secondary carbon. And if a red color carbon is attached to 3 carbon, what could be the name of the compound? Can you guess? If carbon is attached to the 3 carbon, it is called as tertiary carbon. And if it is attached with 4 carbon, it is called as quaternary carbon. And it is represented by 1 degree, 2 degree. But we should not call it as 1 degree, 2 degree. You have to call it as primary carbon, secondary, tertiary, and quaternary carbon. Okay. So do we have pentenary carbon? Do we have pentenary carbon? Yes or no? We don't have pentenary, right? Because the valency of carbon is 4. Carbon can only form 4 bonds. So it cannot form more than 4. Yeah, yes, Ravi. So it is only up to quaternary. Got it? So this is about the isomers and its related information. Now next, we will move on with the IUPAC names determination. Determining the molecular structure using the IUPAC name. Suppose in the exam, if they are giving you the name and they are asking you to find out the structure, what you have to do. This is very important. You will get more number of questions from IUPAC. So they may give you the name and they will ask you to find out the structure, or they will give you the structure and they will ask you to find out the name. So both are very important. So now I have taken 3-ethyl 2,2-dimethyl pentane as an example for you. So what is the first step? So to get a structure from a name, you have to start from the parent chain. You have to start from the parent chain which has root word. So which is the root word here? Pent is the root word. So what I have to do in the step 1, you draw the parent carbon chain with same number of carbon. Okay, so pent means 5 carbon, right? So I have drawn the 5 carbons in a straight chain manner. Then the next step, start giving number to all the carbon atoms. Start giving number to all the carbon atoms in the parent chain. So let me number from the left to right manner. Okay. So 1, 2, 3, 4, 5. So I have numbered. Okay. This is the second step. So first, find the root word and draw the number of carbon chains accordingly. And the second step, give numbers for all the carbons. Okay. Now in the third step, shall I go on to the third step? Is this clear? Up to the second step? Yes. Good. So in the third step, attach the alkyl groups as mentioned in the IUPAC. So who are the alkyl groups? So ethyl is the alkyl group and methyl. 2 methyl we are having. So alkyl groups and the derivation of alkyl group from alkane. All these was discussed in the previous lesson. You can go through that if you are not aware of this or how to find out the alkyl group. Okay. So now the 5 carbon is the parent chain, and to the second carbon and to the third carbon I am having one ethyl. So the formula for ethyl is C2H5, right? So to the third carbon I have attached the ethyl group, and to the second carbon I have methyl group. Okay, 2 methyl group I am having. So it is called as dimethyl. So methyl formula is CH3, right? So it is CH3. So I have attached. Now coming to the fourth step, you have to satisfy the valency of each carbon atom by putting the requisite number of hydrogen atoms. So a carbon should contain 4 bonds around it, right? So you see the first carbon. This first carbon is having only 1 bond. So means how many hydrogens are present? There are 3 hydrogens attached with this first carbon. So in the same way, you check for other carbons also. Like if I'm going for second carbon is already having 4 bonds around it. So there is no hydrogen attached to the second carbon. Okay. Coming to the third carbon, how many bonds are there? 1, 2, 3 bonds are around this carbon. Means only 1 hydrogen is attached with the third carbon. And coming to the fourth carbon, we have 2 bonds around it. Means there are 2 more hydrogens which is attached to it. And to the fifth carbon, there is only 1 bond with that. So there are 3 hydrogens. Okay. If you satisfy by putting the number of hydrogen atom, you will get a formula like this, which is the answer for the given question. Is this clear for all? If it is clear to you, just type yes in the chat box. Yeah, clear. Fine. So now let's try to apply this concept to some compounds. So let me check your concept by giving this test. So write the structural formula for the following compound. So the first compound is 3,4,4 tetramethylheptane. So how we have to start? How we have to start drawing the structure? First rule is you have to find out the root word. So the root word is hept. The root word is hept. Hept means how many carbons? 7 carbons, right? So draw the parent chain, which consists of 7 carbon. Then what we have to do? We have numbered those carbons. So both the steps I have brought down into a single step. Now directly attach the alkyl groups. So you can see in the third carbon 4, 4, 5, in all to all these carbons we have a methyl group attached. Okay. So to third carbon, fourth carbon, fifth carbon, you attach the required number of methyl groups which is given to you in the question, and satisfy the remaining carbon with by putting hydrogen. You will get the structure. Got it? So this is how you are getting the structure, which is very easy. Now let's move on to the second question. 2,5-dimethylhexane. So now in 2,5-dimethylhexane, how many carbon atoms will be there in the parent chain? How many? It is hex, right? How many atoms will be there in the parent chain? Very good, Aisha. It is 6. Yeah, it is 6. So draw the chain and give numbers. Then attach the alkyl groups. So what is the name of the alkyl group? It is methyl, right? So to the fifth carbon and second carbon, you have to attach CH3 group. You have to attach CH3 group and satisfy by putting the numbers. That's all. Clear? Yeah. So this is about the nomenclature. So I hope this is clear to all of you. Now it's already 3:56. So you guys have joined late. So I'm about to complete the class. So from tomorrow onwards, you all try to join on time. Okay. You all try to join on time. Which compound is not clear, Hashira? Second compound is not clear to you. So, is the second compound not clear to you? Shall I explain? Or the first compound? Tetramethyl heptane. Okay. First compound, right? Yeah. So this is, so tetra means 4. Tetra means 4. So heptane means 7, right? 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now to the third carbon, to the fourth carbon, and to the fifth carbon, methyl groups are attached. Methyl means CH3. Okay, methyl means CH3. Methyl groups are attached. So that's why we are giving CH3 to all the system. And each carbon should contain 4 bonds around it. So since the first carbon contains only 1 bond, there should be 3 hydrogens. And second carbon is having 2 bonds. So put 2 hydrogen, then only it will be 4. Okay, like this, you satisfy the number of hydrogen for all the carbons. Clear? Clear now? CH3 means methyl. Clear? Yeah, I hope this is clear. Yes. Okay. Now this is for 2,2-dimethyl hexane. So today we have discussed. Let me summarize the. So I was about to take you the preparation part also, but since you guys have joined very late, so we don't have enough time to discuss the preparation. So tomorrow onwards, you all try to join on time, okay, so that we can discuss more topics. So the first topic is introduction to hydrocarbon. Introduction to hydrocarbon, and the second is the classification we have discussed with the flow chart, and third is the intro to alkanes. Third is intro to alkanes, and what is the fourth topic? Fourth topic is isomers and IUPAC nomenclature. Okay, so try to solve questions from these 4 topics today, and come for the next class. Okay, tomorrow we will discuss the preparation of alkenes. Okay, so if there are any doubt for you, you can put it in the chat box. If there are no doubts, thank you so much for listening the class. Yeah, thank you so much. See you all in the next class. Okay, take care. Bye bye. Yeah, thank you. Thank you. Thank you. Thank you, students.